So we've spoken now about how we can reduce the input into the atmosphere, but now let's talk about the other side of the equation, how we can increase the removal of greenhouse gases and especially carbon dioxide from the atmosphere. So first of all, there are nature-based solutions, which are based on nature, asking nature to help us, both in the oceans and in the atmosphere. And the first one is very simple, afforestation, simply planting more vegetation, more forests. The more vegetation we have on the planet, the more carbon dioxide will be removed out of the atmosphere. We've spoken about this a little bit before. And so if we can increase the amount of vegetation on the planet, which is not easy, we need huge amounts of areas, but we can maybe also use the oceans to increase kelp forests and mangroves in the ocean, coastlines. This can help taking out more carbon dioxide in the atmosphere. And there's a very nice project going on in Africa called the Great Green Wall. You can also see the video in the accompanying material, which is trying to build a green wall of trees going across Central Africa from the west to the east side of Africa, which will have a dramatic impact on the absorption of carbon dioxide from the atmosphere. There are other benefits, obviously, to this as well. It reduces soil erosion, the progression of the deserts, provides shade, various places for animals to live. So there are very many co-benefits for having trees in this region. But the main reason for doing this is to take lots of carbon dioxide out of the atmosphere in this green wall of trees which will cross Africa. Now, another way, one idea of how we can actually enhance the uptake of carbon dioxide using nature-based solutions is something called biochar, which is kind of like producing charcoal. You can see a picture in the middle here of this biochar. Normally, when plants grow, they take up carbon dioxide in the spring when the leaves start to grow and absorb carbon dioxide from the atmosphere through photosynthesis. Some of this goes into the roots, into the soil. And then at the end of the season, coming to the fall and the winter, through respiration, the leaves fall off and this basically decays and the carbon dioxide is released back into the atmosphere. So on the left, we can see the cycle where we can maybe take up 50% of this carbon dioxide we can remove 50%, but this is returned back into the atmosphere. And therefore, we have a net zero withdrawal from the atmosphere. Whatever comes out of the atmosphere gets returned to the atmosphere at the end of the season. But if we go to the right-hand side and we can see what happens with biochar, here we have a process when after we've taken up a lot of carbon dioxide in the leaves, in the branches, in the roots, in the spring and the summer, we can remove some of this biomass and using a process called pyrolysis, where we actually heat up this biomass, but with very little oxygen or no oxygen, that's how actually we produce also charcoal, we can convert that biomass to a stable state where it won't decay anymore. And we get charcoal which will keep that carbon for as long as we want. We could actually bury that carbon or store it, and it can remain for hundreds of years even. And this way we can actually remove, say, 25% of the carbon, produce biochar, and then what's released to the atmosphere and from the ground will be overall maybe 25%, which means we've had net withdrawal of 20% of carbon dioxide from the atmosphere. So here's a process where we can actually remove carbon dioxide through the vegetation and then store it in a way using this biochar. And it turns out that people have found that biochar has many good uses in industry. First of all, for agriculture itself, the biochar can be used for extra nutrients in the soils, storage of water. It's very porous, so it can store water. But if we found out that we can use biochar in the construction industry, even in the food industry, in high-tech medicine, cosmetic industry, many different industries can use this biochar. So if there's a demand to produce this biochar, then we can also, through nature-based solutions, remove extra carbon dioxide from the atmosphere and use it in other ways, or even store this to store the carbon in other locations. Now, those are nature-based solutions, but there are also technological solutions that we can remove physically, sucking the carbon dioxide out of the atmosphere. And these are called carbon capture and sequestration, CCS. There's a pilot ongoing in Iceland at the moment. And the idea is that we actually physically, with huge vacuum cleaners, you can suck the air in and separate out the small amounts of carbon dioxide from the other gases, let the oxygen and nitrogen go back into the atmosphere and keep that carbon dioxide. You could even use that in industry, for example, the beverage industry, to put the carbon dioxide into our Coca-Cola or to any other drinks. But what they're doing in Iceland is converting this carbon dioxide to liquid and pumping it into the ground, into cavities where in the past they had natural gas or oil. And so we have these cavities in the ground where we can put in this liquid carbon dioxide mixed with water. You can think of it as soda water. And in the ground, it reacts with the rocks, chemical reactions, and can form chalk or gypsum, which can be there for millions of years. So there are solutions where we can actually take the carbon dioxide, liquefy it, pump it into the ground, and it can stay there for thousands, if not millions of years. The problem is it's very expensive to do this today, and we need to do it on a huge scale because of the concentrations in the atmosphere. With, again, research and investment, we'll be able to reduce the costs and make this cheaper and more economical, and maybe this could be a solution for taking out the carbon dioxide artificially from the atmosphere. In Iceland, it's easy to do because the energy is free. They're basically using geothermal energy from the volcanoes in Iceland to drive this whole process. So for them, they don't have to pay for the energy. But if we want to do this anywhere else in the world, it will cost us, and therefore we need to use also renewable energies. Now, this is taking the carbon dioxide out of the atmosphere, and there are other ideas of how we can do this. But it could also be possible to take the carbon dioxide out of the oceans. And when we studied about the oceans, you may remember that there's much, much higher concentrations of carbon dioxide in the ocean water than there is in the atmosphere. About 15% of the dissolved gases in the ocean is carbon dioxide, where it's less than about 0.3% in the atmosphere. So if we could take out artificially the carbon dioxide from the water in the oceans, and there are some ideas of how we could do this, converting that, again, carbon dioxide to something, use it, or to convert it to rocks or to gravel that we could use in the building industry, then what happens is that the oceans reduce the amount of carbon dioxide they have inside and can take up more carbon dioxide from the atmosphere. And the oceans, as you've learned, cover 70% of the planet. So if we can reduce the concentration of carbon dioxide in the oceans, this will allow us to take up carbon dioxide from all the oceans and take it out of the atmosphere and enhance the reduction of carbon dioxide in the atmosphere. So these are new research ideas which are just starting now, but in maybe 10, 20 years, we'll see that we'll have carbon sequestration coming out of the oceans, and this will help in the right-hand side of the equation of reducing the amount of greenhouse gases in the atmosphere. So if we go back to where we started, to get to net zero, we need to actually have this balance between what we're putting into the atmosphere and what we're taking out of the atmosphere. And as we mentioned before, and we've seen throughout the course, the input into the atmosphere, the greenhouse gas input, is much, much higher than the output that we see today. And therefore, what we've spoken about today is how we can actually reduce the input and increase the output. And to summarize, basically, there are these 4 different topics we need to focus on to reduce the input. We need to move to renewable clean energies. We need to electrify everything using the clean energies in the first point. Some areas cannot use electricity, so we need to move to synthetic fuels, hydrogen, and other fuels. And then we also need to deal with the non-energy sector. We spoke about agriculture, deforestation. These will all reduce how much we're putting into the atmosphere. And then on the right-hand side of the equation, we have to increase the output, how much we can take out from the atmosphere. And this involves nature-based solutions, increasing the forests, increasing the biosphere in the ocean, but also technical solutions of carbon sequestration in the atmosphere and maybe also in the oceans.